streaming.
God darn it. Okay, good morning, everyone. So for science today, if you go back and look, I posted a video, and the video covers matter. So these first 5 questions can be all answered from watching that video. The video is about, I think it's about 4 minutes long. So if you go to like the science classroom, there's going to be a video for today. And then after that, the answers are all right here. And the reading starts right here. So if, guys, what we're doing today, this is the first unit in physical science. We finished up Earth and space science last week, and physical science is the next topic we'll be covering. About maybe a third of the questions on the science task will be physical science. So we'll be working on physical science for the next couple of weeks. Okay. So this is about structure and properties of matter. And it says everything in our physical world is made up of matter, whether it's synthetic or natural object. A bowl of cereal, a bike pump, or a torrent of hail has essential physical properties that define its character as matter. When we use matter or react to it, we think about all sorts of different ways. If we are playing basketball, we think about where the ball is going to go in a physical space and how we can control it. If we're making a sandwich, we think about the different combination of flavors and how to make the sandwich taste good as possible by combining these flavors. If we're deciding what to wear in the morning, we think about the visual qualities of different clothes, imagining what the most appealing combination might be. As scientists, we think of matter in 2 categorical ways. We can think about its physical properties, or we can think about its chemical properties. Physical properties have to do with the matter itself. Chemical properties have to do with how the matter exists in relation to the matter around it. In the case, say, of basketball scientists, we might think about its properties like its appearance. Round, knobby texture, orange color. Buoyancy, does it float? Yes. Or conductivity, does it carry electrical current? No. Other physical properties, some observable and only discernible under testing, are boiling point, density, ductility, hardness, magnetism, malleability, mass, melting point, and odor. So these include physical properties we can test by just using our 5 sense of properties. We test more rigorously using scientific tools. We can change some of the physical properties of matter while others are fixed unless we alter them with the interaction of other substances. For instance, we can take a big block of cheddar cheese and chop it into tiny pieces, even put it in a blender and turn it into cheese puree. This changes the cheese's texture, but not its color. Also, it still has the same level of facility in carrying electric current. You won't be able to stretch a cheese like a rubber balloon or using a scratch glass like a diamond. The blended cheese will still have the same mass as the original block of cheddar. Put some nachos, have a snack. Okay. Another category, so physical, you guys, is just how it looks, how it feels. There are 5 senses. We see, feel, touch, smell. So that would be kind of the physical properties of any object. Now we're going to get into chemical properties. It says another category of matter is chemical properties. Chemical properties are defined by one kind of matter's reaction to other condition or types of matter on a chemical level. The product of a chemical reaction is irreversible. When wood burns in a fire, for instance, it changes from wood into ash and smoke. The ash and smoke will never be wood again. You can usually tell when a chemical change is taking place because there will be a telltale signal. If a substance is changing color, giving off heat, foaming, fizzling, or bubbling, or producing a sound or a new light, it's probably undergoing some kind of chemical reaction. Next time you're watching fireworks, take a second to appreciate how many chemical changes and reactions are taking place moment by moment, one right after the other, sometimes right on top of one another. While we can appreciate that chemical changes are always happening all around us, it's fascinating to see a display of chemical changes designed to express itself so dramatically. Fireworks are a unique art based on manipulating the changing chemical properties in reactive matters. Chemists who designed fireworks had the fun job of creating exciting looking and sounding chemical reactions between substances. The first part is safety, of course. Fireworks specialists or pyrotechnics are responsible for unleashing those reactions in a carefully choreographed sequence, specifically designed to make them show as tense and exciting as possible. One thing all matter has in common as a basic building block is the atom. Raisins are made of atoms. Glass windows and chandeliers are made of atoms. Your parents are made of atoms. Leonardo da Vinci's painting, the Mona Lisa, is made of atoms. The air we breathe is made of atoms. Atoms are so tiny we can't see them, even with the aid of powerful microscopes. Different fundamental types of matter, we call them elements, and they're all listed on the periodic table of elements and made up of atoms with different but discrete chemical structures. There are about 100 elements, and together those elements compose everything in the known physical universe. Atoms are made up of even smaller component structures. Again, there's no way for us to observe these structures physically. That's what sets them apart from the physical properties of matter, which we are known discernible to our five senses. Those physical properties all answers to their basic chemical makeup. The buoyancy of raisins in a bowl of cereal isn't just a random trait. It's because the types of atoms in the raisin constructed to behave in a certain way in relation to atoms around it. On the periodic table of elements, scientists over time have placed essential atomic types of matter in different groups based on their atomic or chemical makeup. Those basic materials combine in particularly infinite ways. Exciting to think about the creative and organic possibilities that matter holds for the future. Okay. So here are the questions. So what two categorical ways to think about matter discussed in the passage? That would be physical and chemical. Okay, so when you look at something like we use the basketball, we see it's orange, we see it's round, it has little dimples on it, and we wouldn't know by looking at it what that's made of, but you probably know it's made of some sort of rubber or leather, and that rubber or leather has chemical compounds. So two ways of thinking about everything, you guys, just everything, is chemical and physical, even like the table in class. Usually they're gray, but square, round, whatever. That would be the physical. Chemical is kind of what it's made of. What is compared and contrast the physical properties of matter of the passage? It's the basketball. Okay, it's the appearance of the basketball. If a substance is producing a sound or new light, that's probably undergoing a chemical reaction. The explosion of fireworks produces sound and light. Based on the information, was likely conclusion. For this one, it's going to be the explosion of fireworks example of a chemical reaction. Remember they use like burning wood? It'll start crackling. It turns into smoke and ash. So it's actually changing. That's a chemical reaction. Just like a firework too. You light it, goes up like a bottle rocket. It's basically goes up, makes a sound. A Roman candle, it shoots off different colors once you light it. So that's basically an example of like a chemical reaction. A glass of bowl number 4. A glass bowl falls on the floor and breaks into pieces. What kind of change has taken place? So it's basically either going to be a physical or chemical, because those are the only two changes we're talking about. So it is the physical, because it goes from being one piece into whatever, 100 pieces. But it's still glass. The glass is just in smaller pieces. So it's a smaller version of itself. Hasn't basically changed. It hasn't melted. You're not seeing the glass turn into like liquid. It's just smaller, basically, pieces of glasses on the floor. What is this passage mostly about? That would be B, matter. Okay. So it says, read this sentence. In the case of, say, a basketball, as scientists, we might think of its properties, its appearance, round, knobby, texture, orange color, buoyancy, does it float? Yes. Or conductivity, no, it doesn't carry electrical current. What does the word properties mean above? Problems or difficulties, A is not going to be it. Increase or expansions, no. Qualities or characteristics, changes or transformations. So it's its characteristics because it's orange, it's round, it's knobby, it doesn't float, and it doesn't carry electric current. Those are all characteristics of a basketball. Just like if you use yourself, the characteristic is going to be your eye color, your hair color, short, tall, heavy, skinny. Those are all characteristics or properties that we all share. So the answer for 6 is going to be C. Choose the answer that best completes the sentence below. Matter can be thought of in 2 categorical ways. Blank, physical, and chemical. So instead, physical and chemical, A, no. Namely, physical and chemical. That sounds pretty good. Earlier, physical and chemical, later on. So it can be named in 2 ways. So B is the answer, namely. When we talk about matter, we name them in 2 ways, physical matter or chemical. Okay. What is an example of a physical property? And those are all things we talked about if you go up when we use the basketball. Round, knobby, orange, or brown, dimples. All those are physical, okay? Just like us, it'd be our hair color, our eyes, our weight, our height. All those are physical properties. And what is an example of a chemical change? Once again, you're going to use wood or the fireworks. Because once you start heating wood, it starts smoking. It starts basically, it turns like a red. You've seen like a log in a fire, it burns really hot. It turns into ash. You might hear it popping. Those are all examples of a chemical change. And 10, what's easier to observe? It's probably going to be with our eyes. It's the physical, because you can look at something and you know exactly what its physical properties are. You're really not going to know its chemical properties just by looking at it. You have to do some experiments with the chemical. You have to heat it, cool it, mix it with another chemical. So by just looking at something, physical properties, like we just look at someone, we can describe their physical properties, okay? We don't know what all our bones are made of, what all our basically muscles are made of. That's going to be harder to describe, but just looking at someone, their physical characters are right there in the open. Okay. So, and all the answers are right here. So if you didn't get them, you can go back and just check this. And like I said, when you're done, go back and if you haven't already, watch the video. And then from the video, you can answer these first 5 questions. They're all covered in What is the Matter video, and that is posted in the science classroom today. All right, you guys, have a good day. I will send the social studies link shortly.